Ah, that annoying sound. Hop in the car, you turn the key, nothing. But it turns over, yet it don't go. What do we do? We're going to talk about that today. So let's get started. So there's a few things that they're kind of compulsory checks when you were basically looking at diagnosing a no-start situation. Car cranks, but it doesn't start. So one of the first things you're going to look at, does it have spark? If we've got no spark, it's not going to run. So spark's really important. We'll get through some of the details of what can cause no spark in a moment. 2, do you have fuel supply? Now, does your fuel pump work in the back? Are you seeing fuel delivered to the injectors? 3, do you have compression? When you crank a motor over, there should be a certain amount of resistance heard when the motor is cranking. You should be able to hear the cycles of the compression strokes as they come around. If the motor is turning over a lot easier than it normally is, it might be a hint that you've got a compression issue. And things like something as simple as a jump timing belt or a chain can cause a drop in compression in a no-start situation. And 4, if you've got a situation where you have a sensor malfunction that throws the AFR ratios off so far that it can't run, it can prevent your car from starting up. So those 4 things to recap: do you have spark? Do you have fuel? Do you have compression? And you have no codes in the car that could cause AFR issues that it wouldn't start. Now, just because you've got a code in your vehicle doesn't mean the car won't start, but if the right sensor is faulty, such as a crank sensor or a coolant temperature sensor, you could end up in a situation that the ratios are so far out that it can't run with the mixtures that are in the cylinder. Diagnosing, do you have spark at the ignition coil or spark plug? So we're going to actually just take a test light. There's multiple ways to check for spark, but we're going to grab a test light. You could also use a spark tester. You could use an old spark plug. Okay, we're going to actually, now you can do this in a spark plug wire end, or we're going to go right in the coil here, and we're actually going to pull this back a little bit. We're going to look for a jump to the end of the test light pointer, and this will prevent us from getting a shock because there's quite a bit of insulation around there. So we'll look inside of that area. Crank it over, please. Yeah, okay. All right, yeah, we do have a spark. What we're going to do here, we found an ignition coil. Now, some of your cars may have coil over plug style of coils where you've got an individual coil on every plug. What we're actually going to do is test for 2 things on there. We're going to check for power going in to the coil and for a signal to fire the coil. Now, whenever we turn an engine over, the crank sensor through the ECM control is going to trigger the one side of the ignition coil with an intermittent grounding and ungrounding, and every time it ungrounds, it should fire the spark. So what we should end up with is power on one side, and we're going to get an intermittent flash as we take the ground away. We'll send power to the coil to come back out there, so it'll start pulsing on the one side. I'm not quite sure which side is the tack side and which side is, we call that the tack side, the impulse side, and one is permanent power. So we're going to stab these, and we're going to double check and see what we got. I'm going to turn the key on and crank it over. Now, and I've grounded the one end of the test light. I'm going to turn the key on and I'm going to crank it. So I'll turn the key on. Okay, we're just going to touch that little pin in there. We've back pinned it and it does light up, but now we're going to crank it. So I'm just going to put that in there and we'll crank it over. We'll watch the light. There was it was impulsing. So that's telling me I'm on the command side or the tack side of the coil. And that's also telling me 2 things. For me to have a pulse on that side, I've got power going through the coil. So it's doing what it's supposed to do. I'm just going to go on this side. On this side, it shouldn't flash on that side. Other than we're going to have a little dip in brightness because we're cranking and we're using some of the battery power up doing that. So I'm going to put the power on there, or the key on. We touch the test light to it and crank it. We should see that it doesn't pulse. You can see the light was stable. It dimmed a little bit, but it wasn't pulsing. So we know that we have power to the coil, and we also have pulsing on the coil. So we know we're getting a crank signal, so we don't have an issue with the crank circuit as far as the distributor in this case supplying through its ignition module a signal to fire the coil. Now if we got a signal to fire the coil, we should also have an impulse for the fuel injectors to work as well. We're going to check that a little bit later. Now if you, for instance, didn't have an impulse on the tach side of it, then you're going to have to dig deeper into the ignition system, looking at the ignition module and getting into the internal parts of the distributor, looking at even there's a pickup mechanism inside of it that triggers that ignition module, which then in turn triggers the ignition coil. So that's okay. Sometimes you have a car with what they call coil over plug style ignition system, where they have an individual ignition coil on every cylinder, and you want to determine if they have spark going to them. So what we're going to do in this case is fairly simple. So we're going to remove one of the coil packs just to get a sampling to see if that's got spark. We're going to remove the coil pack harness on top of it, just disconnect the connector. And those connectors can be 2-wire connectors, 3 wires, and even 4 wires connectors on some vehicles. If it's not starting because of no spark, we're going to be able to find out quickly. So now what we're going to do is we're going to actually plug that coil back into the harness to just produce it. But at least it's going to tell you if you're producing spark. And we're just going to take that, get somebody to crank the motor over. We're going to place it on a good known ground. Now we've got metallic valve covers, so we'll do that. I'm going to crank it over. And you could also use a test light and inside the spark plug boot there, but this is a long boot, so it'll be hard to see. Okay, crank it. Okay, now what we've got here is a different style of tester. This is a special tester that can be inserted right into any spark plug wire. In this case, we're going to shove it in the end of the coil pack, and we're going to adjust the gap on the end. Oh, we'll give it, give it half a centimeter. I'm going to see if it's going to arc across there. The other end of that little test unit is joined up to the ground over there. Go ahead. And you can see the spark that we have down there. Okay. If you have an older car that has a distributor and it's not distributorless, if you take the distributor cap off the top of the distributor, you're going to see a little bit more about how the ignition system functions on these older cars. So your distributor, what it does is distribute spark to the various spark plugs and sends them through spark plug wires to each cylinder. Central part of the distributor cap is going to have a terminal that runs over to the ignition coil. When the ignition coil fires, releases spark, it runs it to the middle of the distributor cap, and then what happens is a rotor inside rotates, and when it lines up with the specific terminals inside, it can then deliver the power from the center of the distributor's carbon button, where the power comes down to from the outside, and it's going to transfer it over to the specific terminals leading up to the spark plugs. And this little part over here really is essential for getting that spark there. There's a little central conductor that runs across right to the middle. Sometimes what happens is these things get damaged, or that on the bottom of the rotor, what happens is it burns a hole or arcing hole right through the middle of the rotor itself, and it will ground out in the middle of the distributor. So even though the coil fires over here, it doesn't always get to the spark plug. So if you got an impulse with a test light and yet you have no spark to the spark plug wires themselves down at the spark plugs, this little rotor right here can be at fault to cause a no start condition. Now the other thing that sometimes happens is inside the distributor caps, the caps would crack and they'd end up with, I can't really show you that very well in here, but you want to look really, really closely in the cap, there we go, for signs of cracking in the cap, because what will happen is the spark will actually jump from terminal to terminal following those crack lines. So you want to look really carefully around the cap for any what they call carbon tracks that can cause a spark to transfer around the distributor. It used to be years ago that a lot of these old cars, you'd hit a big water puddle, it would get the distributor wet inside, and when it got wet, the car would stay stalled somewhere on the side of the road until you got the distributor apart and dried it with a rag inside. So that's kind of old school, but you may still have a car that has a distributor on it. Okay, we're going to look at one specific wire on here, and it looks like a spark plug wire, and it's the same type of wire. If you have a no start condition, you want to check this. There is a wire coming from the ignition coil to the center of the distributor cap called coil wire. So you want to check to see that high tension wire has got proper resistance. So Mr. Barrett's going to work with me here. He's going to take the wire off between the coil pack and the actual center. He's going to use an ohm meter here. And he's going to probe that both ends of the wires, and we're going to look for the value on that to be under 30,000 ohms, just like you would check spark plug wires. In this case, we got about 17,500 ohms, so that's a good wire. So we've ruled out that we've got an issue with the spark being impaired by the ignition coil wire. So the ignition coil wire is good. We can check every single wire for fault going to our spark plugs, because we can also get a misfire caused by that. But as far as no start conditions, yep, that ignition coil wire is a critical wire. Okay, I just want to show you now inside the distributor. We have on many cars, if they had a distributor, they started putting the ignition module, which is a transistorized little processor that picks up a signal from the pickup mechanism. So right in here, this is called the ignition pickup. And there's a little rotating armature on the inside. You can see it starting to move in here. This part moves around a winding. And when the winding has this little armature rotating around it, there's teeth that line up and misalign, and it concentrates the magnetic field differently inside of this winding. And as a magnetic field fluctuates in there, it causes a trigger impulse to that module, which in turn triggers ignition coil fire. Sometimes what happens is these ignition modules fail and can cause a no start condition. Other times that happens is the wires, two wires, they come out underneath here into the module. If those wires break, it can cause also no start conditions. So one of the tests we often will do is pull the module off, and we'll check those two wires coming out of the little coil in there, that pickup coil, to see if those wires are broken and if there's continuity coming through it. All right, so that's the insides of an ignition system. Okay, the next thing I want to do, guys, is we're going to actually cycle the key. We're not going to actually crank it, although you could just crank it briefly and then listen. We're going to see if there's a sound coming from the fuel pump, and one of the nicest way to do it is actually go right down close with your ear to the, take the cap off and listen for a hum for about 2 seconds when you put the key to the on position. You don't have to crank it, just put it to the on position. Go ahead, Scott. And I can hear the hum on it. So I know I've got a fuel sound, and it will run for about 2 seconds. But if you don't have a sound down there, then you know that you've got a fuel pump that's not delivering fuel, or no electrical signals going to the fuel pump. Okay guys, I got a motor here that I'm gonna use to demonstrate fuel pressure checking. Now, if you have a car that has a fuel rail with a end on it, like either a port or a test port for pressure, you can put a little adapter in there. Tighten it up. Take your fuel gauge, and usually there'll be a hose that you can attach to this as well to bring it remotely to where you need it. In this case, I'm just going to put a fuel gauge on there, top it down, and at this point what I will do is I will cycle the key and I'll test how much pressure is going to be in the fuel rail. Now you have to check your specific car for the amount of pressure it should generate, but if you're not developing pressure on that, you know that you've got a problem with the injection system. Now guys, things that cause fuel pressure issues could be a defective fuel pump fuse could be faulty, you could have a fuel pump relay that's defective in there, and sometimes it's a crank sensor issue. So there's multiple things that can cause no delivery on the fuel to the fuel system, but at least you're isolated the problem is fuel system related, and then you go about diagnosing it accordingly. Okay, now guys, on some cars we don't have a actual test port for checking for fuel pressure to your engine. So on some cars, if you're trying to check if your car is actually getting fuel pressure, you can go to a rail, at the end of a rail, and open up a fitting on it, or you can find somewhere where there's a junction in the line and open that line up. Now we have a union right here with two flare nuts on it, so we're actually going to crack that line loose, and then we're not going to start the engine, but we're going to turn the key on and see if that fuel pump is going to develop pressure. Now this won't tell us exactly what the pressure is, of course, but it's going to tell us whether or not that fuel pump is sending pressure to the fuel rail. So I'm going to open that up a little bit, and already just opening it, I can tell there was pressure in the line that squirted out. But I'm going to turn the key on, and then I'm going to crack the line, so it'll prime the line inside. Okay, now I'm putting a rag under here for safety reasons. It's going to leak a little bit of fuel out, so we're going to want to catch that. Good idea to put your safety glasses on when you do this. And you can see that fuel pressure coming out of there, and I'll close that back up. Getting quite a bit of pressure, so I know I've got a fuel pump delivering pressure to the injectors. Now the next thing we're going to do is just to make sure we're just going to see if we actually got our injectors pulsing when they're supposed to. We're going to use a Noid light to do that. And what's a Noid light? We'll explain that. Okay, so guys, we're going to talk a little bit about checking for injection signal going to the injector themselves. And there's a couple of ways you can do this. You can actually do this by ear while you crank the motor over using a stethoscope, see if there's going to be a pulse on there. But I also want to show you how to check for power to the injection connectors going to the actual injector. So what I'm showing you right now are a set of what we call Noid lights, and they're actually just little tiny bulbs with terminals that will go into the injection connector, and there's quite a few different styles of them. Alternately, you can also use a test light, works just fine. So we're going to show you a couple of ways to do that. First thing, not all cars have easily accessed fuel injectors that you can get to, so we happen to be lucky on this particular model. We got a little Cavalier here that we're going to pull one of the connectors off, and that'll actually fit right onto the fuel injector. And because the fuel injector is just a little solenoid, when we send energy to it in a ground signal, it's going to pulse the injector, opening it up and sending fuel into the engine. I think that's the right one. And all I'm going to do is go into the car, I'm going to crank it, and we're going to watch to see if there's a pulse at that specific injector. So because it pulsed, you know that injector is working. So we have what we need going to that specific injector. Now we could, if we had a misfire on an engine, you could take that Noid light, N-O-I-D, and move it to any other of the other injectors and see if they're all receiving power. Nice simple way to test it. Alternately, if you don't have one of these guys, you could simply use a test light. There's one thing I usually do when I do this. You're going to remember that with a test light, you should have one side that's going to have power on it and the other side is going to have ground. So, okay, so now what we can do alternately, we got to be careful when you do this because you don't want to short terminals together. And we're not going to insert this little pin here I got into these terminals, so I don't want to spread those. But I can now have somebody crank it over, and using a test light the same way as a Noid light, I can get that unit to pulse on there. Right. Listen to the sound of the motor when it rotates. If it's rotating very, very easily and you're not hearing any impulses of compression when you rotate it, it's a sign that you have a motor that may have jumped a timing belt or a timing chain on it, and you can lose compression quite quickly as a result of that. So let's just turn this over and let's listen to the sound of this motor. You can hear that sound on there. You can hear the actual impulses of the compression as it rolls around. If a motor had no compression as in the case of jump timing belts or chains, you'd almost hear a smooth kind of running, almost like a sewing machine sound, indicating that you could have a compression issue with that motor. Then you'd want to go further on with that and then take out the compression testers and start testing the individual cylinders to see if you actually got proper compression values. Now, likely in most cars, about 125 to as high in some cases as 165, 180. Some will even go up close to 195 pounds of pressure. Now, you can also find specs for your specific vehicle. If you look around, manuals aren't very, very good for that, but you can compare it to other vehicles as well to get a read on whether or not your vehicle is at a proper value. If you see low pressures like 50, 40, 60 PSI, 80 PSI, you've got something going on. Hey guys, I want to talk a little bit about checking for a crank signal using a scan tool. Now, I could plug a scan tool down below into my OBD2 port and then put it on RPM function. So bring up your live data, put it on RPM, so your RPM's on your screen, and then crank it and look for an actual rise in RPM on your scan tool. If you see that you're getting a rise on RPM on your scan tool, that's telling you that your car is sending a crank signal to the computer. So it should be at that point able to send a spark to the ignition coil, cause the ignition coil to spark rather, and cause your fuel injectors to fire. So if you're getting a crank signal, you know it's not related to the crank sensor or distributor pickup on there. So it's a good thing. I've got another special little device here that is you can use instead of using a plug-in scan tool, and this is a Bluetooth. Sometimes they're called dongles or adapters, and this will plug right into your OBD2 port, and you can actually use your phone to get your codes out of it. So I'm going to plug this in, and I'm going to do something with my actual iPhone. I'm going to actually put it on screen record and show you how the app works. So we're going to plug in, turn the key on, and it'll switch over to screen record, and you'll see what's coming up on my iPhone screen. To my app called Blue Driver. So I'm going to just open up my icon that looks like that. So once I do that, the screen will come up and I can go into entering my vehicle data if I want right here under vehicle information, and it'll go by the VIN number that's in the car, or you can manually enter it in. I'm going to use the automatic data, so at this point I'm just going to enter, and so that's exactly what I want. And now I'm going to go up to, okay, we're going to read the codes on this thing to see if there's anything in this specific car that comes up. And I'm just going to check the check engine light, so it's going to do a scan on it. Now, knowing the codes is pretty important, because if you got a problem with one of the sensors, you want to know that, otherwise you can chase your tail. And it shows that there's no code showing on this one. If I did have codes, the nice thing about this scan tool, whether it's wireless like I have using through my phone, or a more robust, bigger scan tool, you can still clear the codes. And I don't need to clear the codes, but I would hit the clear codes function on it right there, and it asks me which codes I want to clear. I don't have to clear any of them, so I'm just going to cancel out of that. In this case, I pre-selected the RPM on here. I went up in this little wheel icon, and I have all these different, what they call PIDs, which is the information that I want to pull up. It could be related to engine RPM. I'll pull up another one just so you can see it. I can pull up the throttle position sensor if I wish to, or the, I'll pull the mass airflow sensor up, but then I'll go back on it, and you can see the gauges coming up. You can also customize them to look like graphs. Now, what I want to do is crank this motor and see if I get an RPM signal on there, and if it does, it tells me I'm getting a proper response from the crank sensor, or from, in this case, I have a distributor. So you can see right here when I crank it, it's giving me an RPM signal, and that's telling me that I am sending a signal over to the ECM, so it should start firing the spark plugs and also the fuel injectors. So you can use a scan tool to check the status on your crankshaft sensors and your camshaft sensor. So just remember, when you have a problem with no start, you're going to be checking for fuel delivery, spark, compression, and if there's any codes present in your car. How you proceed from there is going to be dependent on what you find, and of course you're going to have to consult a manual to follow up with a repair.